In the first example, we are only given angle M2 and we are looking for angle P, which is this angle M1, which is this angle, and angle O1, which is this angle. Point P lies on the circumference of the circle. When you look at this four-sided shape, it has all the four corners lying on the circumference of the circle. So that makes it a cyclic quadrilateral. Theorem 5 states that the opposite angles of a cyclic quadrilateral add up to 180 degrees. So this angle plus this angle add up to 180 degrees. To find this angle, we minus 64 degrees from 180 degrees, which will give us 116 degrees. So the size of angle P is 116 degrees. To find the size of angle M1, we need to understand that a diameter is a line that passes through the center of the circle, and it is 2 times the length of the radius. The line SN passes through the center of the circle, so this line is a diameter. Theorem 3 states that the angle subtended at the circle by a diameter is a right angle, and we say that the angle in a semicircle is equal to 90 degrees. To understand this theorem, keep in mind that when two chords are drawn from the two ends of a diameter and meet at one point at the circumference of the circle, they form a 90 degrees angle at the point of contact. So this whole angle, M1 plus M2, is equal to 90 degrees. Therefore, M1 is 90 degrees minus 64 degrees, which will give us 26 degrees. Angle O1 is 2 times the size of angle M1. Theorem 2 states that the angle at the center is twice the angle at the circumference. Therefore, if M1 is 26, then O1 is 26 times 2, which is 52 degrees, so the size of angle O1 is 52 degrees. In the second example, we are looking for the size of D angle GF, which is this angle T, which is this angle, and G angle EF, which is this angle. D, E, F, and G are points on the circumference of the circle. Therefore, this four-sided shape is a cyclic quadrilateral. Theorem 6 states that an exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. This is the exterior angle, and this is the interior opposite angle. Therefore, angle E4 is equal to D angle GF, which is equal to 72 degrees. Theorem 4 states that an arc or a chord of a circle subtend equal angles at the circumference of the circle. We say that the angles in the same segment of the circle are equal. Try to look at this theorem this way. If you have this shape and you have all the four corners lying on the circumference of the circle, then these two angles are equal and these two angles are equal. So if this angle is equal to this angle, and we know the size of this whole angle, which is 72 degrees, to find the size of angle G2, we can then minus 16 degrees from 72 degrees. 72 degrees minus 16 degrees is equal to 56 degrees. Therefore, the size of angle T is 56 degrees. These two lines are parallel to each other. As long as these two lines are parallel to each other, then these two angles are alternate angles. Alternate angles are equal, so this angle is equal to this angle. We already know the size of angle G2, so that tells us that we also know the size of angle E1, which is also 56 degrees. This is a straight line. We know the size of angle E4, and we know the size of angle E1, and we also know that the angles in a straight line sum up to 180 degrees. So to find the size of this angle, which is G angle EF, we minus these two angles from 180 degrees. So 180 degrees minus 72 degrees minus 56 degrees will give us 52 degrees. So the size of G angle EF is 52 degrees. Thank you for watching. I'd like to know where you find a challenge in this chapter, so please leave a comment and watch more videos on this channel. We'll see you on the next video.